Hello and welcome back. In this video, I will show you how to integrate a new beam-to-column-joint finite element into the OpenSees source code. Specifically, we will be adding the Inno3DPnPJoint element. This element is developed for innovative 3D plug-and-play joint connections, and you can find detailed information in my PhD thesis and other various papers. Check out the links in the video description below. Before we start, make sure you are comfortable with downloading, compiling, and testing the OpenSees source code. If not, refer to my previous videos or other relevant sources. Alright, let's get started. First, it is crucial to identify the files requiring modification. This can be achieved by searching for similar contributions using the appropriate keywords. The search can be performed in several ways. For example, File Explorer. As this video is about joint element, I will use the joint2D keyword. Go to the search bar and under Advanced Options, be sure that File Contents is selected. Then perform the search. The search is complete and you can see here the list of files containing the keyword joint2D either in their title or in their content. Of course, these results need to be filtered and only the relevant files to be modified. Another way is to use Visual Studio. You can use the Find in Files, type the keyword. Usually it's good to have match case selected and then perform the search. Similar to File Explorer, filter the results to focus on relevant files. Another possibility is to search directly in the OpenSees source code on GitHub. For this, navigate to the repository, go to Pull Requests, select Closed, and search for relevant keywords. I will use the keyword element. It returns one result on the first page, yes. Let's check if this pull request really adds an element to the source code. Yes, it seems so. Now let's check the files changed. Okay, so here on the left side you have the files that need to be changed or added in order to contribute with an element to the OpenSees source code. To keep this video as short as possible, I already performed the previously shown searches and I created a file containing all the files that require modification and also the code that needs to be added to those files. I named each required modification as a step, so we will follow a list of 10 steps. And next I will walk you through each step one by one. Step 1, we will copy the CPP and header files developed for the beam-to-column joint element to the following destination. Here is the CPP and header file, so we'll copy and we will paste in this path. In step 2, we will open Visual Studio and we'll add the recently added files to the joint project. From step 3 to step 10, we need to modify already existing files. I have already opened the files that require modification to save time and to keep this video short and concise. You can see them on the right side of the screen. Additionally, the code that needs to be added to the existing files has been added already. However, I will walk you through each file individually. As you have already noticed, I added 2 views in Notepad++. On the left side we will see the file that I created and which contains the required modifications, and on the right side we will look at the existing code files. Next I will highlight on the left side the code that needs to be added, and on the right side I will highlight where that code was introduced. Step number 3, step number 4, step number 5, step number 6, step number 7, step number 8. Here you need to replace the triple X with the next consecutive number, which in this case was 263. After selecting the number, it's good to perform a search inside the file to be sure that this number is unique and has not been used before. Step number 9. Step number 10. I have seen that this numbering has been discontinued and that the recent contributions don't modify this file. Therefore, this step might be redundant. Next, the only thing left is to rebuild the solution. The build succeeded. Next, we will test the files, the executable and the Python files. So I already prepared some test files, both for Tcl and Python. So for Tcl, I will open the source code and copy the executable. Okay, it works. And now Python. For Python, first we need to copy the path of the pyd file. I will save it. Then I will open Anaconda. I will change the path to the folder where I have the py files. And now I will run the file. Okay, this also seems to work. This means that the new beam-to-column joint element, Inno3DPnPJoint, has been successfully integrated into the source code. Now the only thing left is to push the code to the main repository, which will be done in the subsequent video. If you enjoy my content, consider supporting my work through my Buy Me a Coffee page. Thanks for watching. See you in the next one.